So let's take a look at glycerides. Glycerides always involve a molecule known as glycerol. Glycerol has several names. Sometimes it's referred to as glycerin, which to me is a terrible misnomer that implies something completely different about it than is reality. But here's glycerol. You need 3 carbon atoms chained together. Each carbon will have hydrogens, and then each one will have this, which is called a hydroxyl group. It's an oxygen with a hydrogen bonded to it. Now this hydroxyl group is what turns organic compounds, which are things that have carbon and hydrogen as their primary structure. That makes them organic. But when they have a hydroxyl group, an OH, that turns the things into an alcohol. So glycerol is a triple alcohol. We call that a triol. In fact, officially, this would be called 1,2,3 propane triol. 1,2,3 propane triol. Propane is a 3-carbon hydrocarbon. So imagine that there are no oxygens here, that the hydrogen is bonded directly to the carbon, just no oxygens. We would have propane. Propane, you may be familiar with. Most people are. You can buy tanks of propane at all sorts of stores. You might have a propane gas grill. You might even heat your entire house with propane that would have to be delivered to your home. Now, the OL suffix here tells us that the compound is an alcohol. Being a triol means that it has 3 of these alcohol-forming hydroxyl groups. Some people call them hydroxy. I was taught years ago hydroxyl, and it's a habit that won't go away. The 1, 2, 3 tells me that the 3 alcohol functional groups, the 3 hydroxyls, are on carbons 1, 2, and 3. Carbon number 1, number 2, number 3. Okay, so that is glycerol. So again, glycerol is one of the most common names for this. It is sometimes referred to as glycerin, with or without the E on the end. To me, that implies that it's a totally different type of compound. An INE ending generally implies that something is an amine, and this is not. It is an alcohol. So that's one of many misleading names that you'll find in organic chemistry. Now, glycerides, as we saw earlier, can either be neutral or phosphoglycerides. I'm going to focus mainly, at least for now, on neutral glycerides. A glyceride, also known as an acylglycerol, is going to have this glycerol, and then it will have 1, 2, or 3 things attached to it that are called fatty acids. Now, fatty acids is actually supposed to be the topic of another section of this, but I may just go ahead right now and tell you about fatty acids. So fatty acids are acids because of this structure right here. This is called a carboxyl group. Carboxyl. It is a combination of something called a carbonyl group, which is this between my fingers, a carbon double bonded to an oxygen. And then it has the hydroxyl group, which is the OH. So put those together and we get a carboxyl group. things that have a carboxyl group in their structure are referred to as carboxylic acids. So we can tack IC acid onto this word carboxyl and we get carboxylic acid. There are lots of different carboxylic acids. They are fatty in the sense that they have chains of carbons extending out from the carboxyl group that can be anywhere from 3 to, I believe I've seen some as numbered as high as 30 carbons. Most of the ones we're going to be concerned with have anywhere from 6 to 20 carbons in this chain. But this chain extending on out here for any number of carbons tends to have nothing in it but carbon and hydrogen. And that portion of the molecule tends to be insoluble in water. And as I had said in the first video, one of the keys to something being a lipid or a fat is that it's not water soluble. One of the terms we use for hydrocarbons that are long chains of carbon is aliphatic. So, again, a glyceride is going to have glycerol and at least one fatty acid. Now something has to happen here, and that is that we're going to have a reaction that's going to remove, we have this OH and this HO, and what's going to happen is that out of those two H's and two O's, two H's and one O will be removed. I'll just circle it this way because that lets you see H, H, and O. So that's water. Okay, so the water gets removed. That causes this oxygen over here to be bonded directly to this carbon. Now that is something that generally in organic chemistry we have reacted an alcohol with a carboxylic acid and removed water. And that is a dehydration synthesis, or a condensation reaction is another term for these reactions where water is removed. And that forms something called an ester. Okay, so we just created an ester linkage by joining what was a carboxyl group to what was a hydroxyl group by the removal of water. So at that point, we have glycerol with one fatty acid on it. We have a monoglyceride, M-O-N-O, mono, meaning one. We can come along then and add more fatty acids to this. And if I were to put another fatty acid here, and that's just a chain of carbons of unspecified length, then again remove water, I would have a diglyceride, and then the one that we really want to spend most of our attention on, if we add a third fatty acid here and join it to the glycerol with an ester linkage, then we would have a triglyceride. So the majority of lipids that we think of from a nutritional standpoint, things that we know we're going to consume these in food, and we look at what they're made of and how they're broken down, they're going to be triglycerides. Okay. Now, these drawings can be simplified, and quite often they are. We can draw propane And I had shown you propane as, let me draw it here. Propane is 3 carbons, and it would be surrounded by 8 hydrogens, like this. And let me tell you, this gets old writing all of these C's and H's. So once we understand how many hydrogens there are going to be, and the basis for that is that every carbon needs to have 4 bonds around it in some shape, form, or fashion. Okay? Once we know and are confident in a student's ability to recognize, well, there's a carbon and it's bonded to another carbon over here, so it has to have these 3 hydrogens around it, we start getting lazy. And we draw something like this. And we've got 2 line segments, and it is implied that there are carbons at the ends of those line segments. So that implies 3 carbons. And then if we were to show a line segment from here but put an oxygen at the end of it, and one here with an oxygen, and one here with an oxygen, there's a carbon at the end of a line segment unless you indicate that there's something else. So that's what I did here. I indicated that there are oxygens. So from there, we can go to a carbon, and we'll show that it has an oxygen joined to it with a double bond. And then from there, we'll draw a line down, and there's a carbon here, 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 and so on until we get enough carbons drawn out. So we can do this, and zig and zag, and we can do this. And this simplified structure takes all of this up here and reduces it down to just some squiggly lines. But once we learn how to read these squiggles, then it's a much easier way to write it. Now, I just said something a minute ago, and let me elaborate on that. This is a foundational concept in organic chemistry. Carbon needs to form 4 covalent bonds. It can do that in 4 ways. Carbon can have 4 single bonds around it. It can have 1 double and 2 single bonds. It can have 2 double bonds, or it can have a triple bond and a single bond. So these are the 4 bonding patterns found in carbon, but it always involves 4 bonds in some way. This double bond here, that's 2 bonds in 1. And so 1, 2, 3, and 4. Over here, this carbon with 2 double bonds, that's 1, 2, 3, 4. Over here on the carbon with a triple and a single, that's 1, 2, 3, 4. So we look at the carbon right here. It has a single bond, another single bond, and a double bond, giving it 4 bonds. So once we know that, we can figure out how many hydrogens are needed on a carbon to give it its 4 bonds. All right. So at this point, I really need to talk a little more about fatty acids. And again, I'm kind of getting ahead of myself, but we really need to see how this works. So we start with a carbon that's double bonded to an oxygen. We come down here at about a 120 degree angle. We need an oxygen, and it'll have a hydrogen on it. And over here, about another 120 degrees, we have another carbon. The smallest carboxylic acid that is considered to be a fatty acid is this one that has 3 carbons in it total. Now, as I was mentioning, we see this carbon in it. So far we see 2 bonds on it. So we know it needs 2 more. And we're just going to use hydrogens to fill that out. This one here only has 1 bond, so it's going to need 3 more. So again, we can draw this more simply this way. So this represents all of this. Now this carboxylic acid with only 3 carbons has a couple of names, but the one I'm going to focus on is this one, propionic acid. Propion translates as first fat. This is considered the first of the fatty acids, the shortest. Now if we take this, if we extend that chain of carbons and make it a 4-carbon carboxylic acid, 2, 3, 4, then of course we've got to flesh out how many hydrogens are needed. So it's going to be 2 here, 2 up here, and 3 on this one on the end. That gives us, I'm going to show you both names here. International Union of Pure and Applied Chemists, or IUPAC, would call this butanoic acid. Its traditional or common name is butyric acid, and that is taken from the Latin word for butter, butyr. And butyric acid stinks. It smells awful, and it gets its name from butter. When butter goes bad, the term is when butter becomes rancid. This is one of the products that you will smell, is butyric acid. All right. These fatty acid chains that make up a triglycerol, a triglyceride, are going to be things like butanoic and propionic acid, although usually they're longer than that. So I really need to shut this video off at this point. We're approaching 18 minutes. It'll get a little unwieldy. So I've got the stage set here. We've talked about glycerides, how they can be mono, di, or triglycerides depending on the number of fatty acids bonded to the glycerol. We've looked a little bit at fatty acids. We're going to do more with that. Still need to talk at some point about phosphoglycerides, but I will save that for later. So that's going to be it for this one, and I'll come back in the next video and talk some more about fatty acid.